Hi, everyone. So in the previous session, you got an introduction to the Darwin Core standard, its structure, and the required fields that you need to populate in order to publish your data to OBIS. So now that you know what the mapping is between your raw data and the Darwin Core standard, it's time to start cleaning up your data to align with the conventions described in the standard. So in this brief session, we'll go over the three most common conversions that a data set will likely have to undergo. And so these include ensuring that your dates follow the ISO 8601 standard, making sure that your scientific names match to an authoritative resource, and ensuring that your latitude and longitudinal values are in decimal degrees. Now, thankfully, there are packages in both R and Python that can deal with the standardization of these fields programmatically. The exercises that are listed below are intended to kind of give you a sense of the variability that we've seen in data sets. There are multiple roads that lead to Rome, and the options that are listed below and the packages that are listed below are not the only ways to deal with the conversions, but in our experience, they are the ones that we have encountered most often. So to begin, it's important to get your dates in order. Dates need to be in the ISO 8601 format, which means that there is a 4-digit year, a 2-digit month, and a 2-digit day separated by a hyphen. Yeah, ISO 8601 dates can represent moments in time at different granularities or different resolutions, as well as at an interval, which use a slash as a separator. You can also record your time in ISO 8601, but you'll have to make sure that you include the time zone. Date and time within the ISO 8601 standard are separated by a T. Timestamps can also have a time zone indicator at the end. Now, if you do not include this indicator, then it is assumed that the time recorded or provided is the local time. Personally, I find it good practice to standardize the date time to UTC, in which case the date time is followed by the letter Z at the end. Now, important things to consider are whether your sampling event takes place over multiple time zones or throughout the year, where daylight savings time might have to be taken into consideration. Thankfully, there are people that are much smarter than I that have thought about this and have developed packages in both R and Python to help deal with this. And below are some of the examples and solutions in Python and R for them. Now, the second thing that I want to touch on is matching your scientific names to worms. OBIS uses the World Register of Marine Species, or WORMS, as the taxonomic backbone for its system. The key Darwin Core term here that you need from WORMS is the scientific name ID, which in WORMS is the life science identifier, or LSID. You can also grab other taxonomic information such as the taxonomic rank or other taxonomic hierarchical information from WORMS. Now, similar to when working with date and time, there are different ways and packages to grab this information. One method is to use the WORMS taxon match tool, which accepts a list of scientific names where each row is a unique scientific name, and then the tool provides an interface for you to select your match, and this can greatly help when you're dealing with names that are slightly misspelled or in an ambiguous format. The other way to get taxonomic information is to use various packages in R. For example, in R, there's a package called worms with 2 R's, and in Python, there's a package called pyworms, just a single R, that can help you retrieve taxonomical information. Now, finally, standardizing and making sure that your coordinates are properly listed. There's this third section here. The latitude and longitude of your coordinates of your sampling events need to be standardized to decimal latitude and decimal longitude, as the previous session covered. And decimal latitude and decimal longitude should be in decimal degrees as well, as the name implies. Now, decimal latitude should be within the range of -90 to 90, where the -90 and 90 are inclusive. And decimal longitude should be in the range of -180 to 180 inclusive. Now, the requirement for decimal latitude and decimal longitude is that they must be in decimal degrees, as the name implies, and in WGS 84. Now, WGS 84 is the required coordinate reference system of your observations for Darwin Core, and should be recorded under geodetic datum. OBIS and GBIF will assume that data shared to these repositories and the data recorded within decimal latitude and decimal longitude are in this geodetic datum WGS 84. And so we highly recommend checking the coordinate reference system of your observations. And if the coordinates that you're using are not in WGS 84, then you will have to convert in order to share your data to OBIS. Now, helpful packages in this instance are, for example, GeoPandas in Python, as well as RGDAL and SP in R. Now, a few tips when standardizing or converting your coordinates. If at all possible, it's best to extract the components of the information you have in order to compile the appropriate field. And when converting, try to split it out into its component pieces, making sure that you keep track of which values are latitude and which values are associated with the longitude information. Additionally, consider how accurate your observations are, and therefore how many units after the decimal you want to record or provide in OBIS. Now, feel free to work through all the exercises in this session to get a better understanding of some of the packages used in cleaning up your data and how R or Python can help you with this. Some key points or takeaways from this session would be that when you're doing these conversions, it's best to break out your data into separate component pieces. This can be helpful not just for coordinate data, but also for date and time. And there are definitely packages within R and Python that can offer a relatively easy solution. If these do not work, then an alternative solution is to use regular expressions to, for example, align your date strings to the ISO 8601 standard. As said, the ISO 8601 standard is a required standard that you would have to use in order to publish your data to OBIS. Now, another requirement, for OBIS is providing the worm's life science identifier in the scientific name ID column when you're recording or providing your taxonomic observation data. So I hope this is useful. If you have any questions with regards to the examples provided, please feel free to reach out to the team, and otherwise, good luck with the rest of the workshop.